Hola! How you doing? Yogi here again. This is the second video in a series of 7 looking at ratios. In my last video, I introduced the definition of a ratio as a comparison of two or more amounts of the same type and explained how ratios are used in many areas of life. I talked about how ratios can be written in words using the colon symbol, or when two numbers are being compared as a fraction, decimal, or percentage. The order of the numbers stated in a ratio was shown to be important, and how ratios can be part-to-part ratios or part-to-whole ratios was discussed. The important step of simplification was also mentioned. In this video, I want to focus a bit more on this last idea of simplification. There are a few tricky situations that can come up when simplifying ratios that I want to go over. So, let's get into it. In this example, before we write a ratio down, we must realize that each quantity in a ratio must be expressed in the same size of unit. Since the width has been given in centimeters and the height has been given in meters, we can't just write 80:196 because the size of each unit in this ratio is different. We need to first convert both measurements to the same unit. Suppose we decide to convert 80 centimeters into 0.80 meters. Now we could write the ratio of door width to door as 0.80 meters is to 1.96 meters. Now notice that you don't write the units, in this case meters, as part of the ratio. However, the ratio 0.80 is to 1.96 now represents another issue. Ratios should generally be written using whole numbers, though there are some special exceptions I'll discuss in another video. We can overcome this issue in this example by multiplying both numbers in the ratio to give 80:196. Now we can do that by first multiplying the number on the left by 100, which will move the decimal place twice to give us 80. And if we multiply then the other side, the other number on the right, by 100, that will also move the decimal place twice to give us 196. Now this ratio, 80:196, has been written using whole numbers. The last thing we should check is if the ratio is in simplest form. Are there any common factors for 80 and 196? In other words, are there any numbers larger than 1 that divide evenly with no remainder into 80 and 196? In this case, 4 is the highest common factor. So by dividing both numbers in the ratio by 4, 80 divided by 4 is 20, and 196 divided by 4 is 49. By dividing both numbers in the ratio by this highest common factor 4, we get the final ratio in simplest form of 20:49. This example has demonstrated how to deal with ratios where different sizes of units have been used and decimal numbers have also been encountered. It has explained the process of simplification by looking for common factors. Suppose a pancake recipe involved mixing cups of flour, milk, and sugar in the ratio 4.5:2:1. At the moment, this ratio has not been written in the right format. One of the numbers is not a whole number. When a mixed fraction such as 4.5 appears in a ratio, the first step is to convert the mixed fraction into an improper fraction. Recall that to do this, the new numerator, the number on top, the new one, is going to equal to the original numerator, which was 1, added to the whole part times the original denominator. Remember to use order of operations correctly by carrying out the multiplication out first and then adding on the original numerator. The denominator of the improper fraction is the same as the original denominator, which was 2. So the mixed fraction 4.5 is equivalent to the improper fraction 9 over 2. So the original ratio of 4.5 is to 2 is to 1 can be rewritten as 9 over 2 is to 2 is to 1. However, we still have a fraction in our ratio. However, what we can do now is multiply every number in that ratio by 2. And when we do that, we will get a new ratio of 9 is to 4 is to 2. This ratio is in its simplest form and is made up of whole numbers. This example has demonstrated how to rewrite a ratio involving mixed fractions so the final ratio contains only whole numbers. Let's look at a slightly different pancake recipe. Suppose this pancake recipe involves mixing cups of flour, milk and sugar in the ratio 4.5 is to 2 is to 1/3. A healthier recipe because it has less sugar. At the moment, the ratio has not been written in the right format. Once again, we find that it has fractions in it. The first step, remember, is to convert the mixed fraction to an improper fraction. And if we did this, we would have the ratio 9 over 2, as in the previous example, is to 2 is to 1/3. The difference is now, in this particular ratio, we have two fractions to deal with. To be able to write this ratio correctly using whole numbers only, this time we need to find a common multiple of the two denominators. So we have the denominator 2 and the denominator 3. What are some multiples of 2 and 3? Well, multiples of 2 are 2, 4, 6, 8, and so on. Multiples of 3 are 3, 6, 9, 12, and so on. We can see that there is a common multiple, in fact the lowest common multiple, the LCM, of 6. By multiplying all the numbers in the ratio by 6, we can get a ratio that only has whole numbers in it. Let's do that now. So if I multiply each number in the ratio by 6, I will get a new ratio of 27 is to 12 is to 2. This ratio has been written using whole numbers only and is in its simplest form. That's it then. You've survived another maths video where we've looked at some tricky cases of simplifying ratios. We've seen how different units have been handled in ratios, how mixed fractions and other fractions can be changed into whole numbers, and how factors can be used to simplify ratios. In the next video, RAT003, I'll investigate the use of special ratios called unit ratios and the concept of scale factors. Until then, adios.